the next class after tomorrow. I thought we needed another day of review, so I couldn't have, even though that's shortening our review for the exam, which here we are starting in our review sheet that we were working in last time. We're starting with 13B. I know that's not where we ended, I just explained the method to my madness here. So we're going to start with 13B. You need to know how to do it already. So we are sketching this. Okay? Well, if you recall, back when we did these before, in the very beginning, this is a cosecant. Personally, I think the easiest way to sketch a cosecant is to sketch the sine first. Remember how that works? And then you drop in the asymptotes and flip the curve. So I'm going to pretend this is a sine. And I'm going to graph maybe 2 sine 1/4 x. So what do I know about this sine curve? Well, first thing I know is it's upside down. Second thing I know is its amplitude is 2. And the third thing I know is its period is 2 pi divided by 1/4, so its period is 8 pi, which means that the whole shebang gets accomplished in 8 pi. How does that look to everybody? Okay? Now, that would be the perfect picture if that had been the equation. It is a cosecant. So any place that I cross the axis, that is a 0. If the sine is 0, the cosecant will be undefined. So I'll drop in my asymptotes where I cross the x-axis, and then I will turn my curves upside down. And the black thing is the answer. So whether you leave the pink one in or not, just make sure that you identify, like make it heavy and dark or something, this is the answer. All right, is that okay with everybody? All right, 14. Okay, so I remember from last year, these were confusing. So I think the easiest thing to do is just to remind ourselves, what is this problem saying? You don't need to write all this out, but you need to understand, this is what it's saying. The angle whose sine is x over 3 is the same as the angle whose cosine is negative root 3 over 2. That is exactly what that equation says. Okay? Now, what do I know about this angle? Well, not much, because it's an x. Let's step over here. What do I know about that angle? I know that the cosine is x is negative root 3 over 2. So what does that mean? What kind of an angle has an x that's root 3 over 2? Pi over 6. But it has to be in quadrant 2 because it's negative. So this guy right here is 5 pi over 6. Would you agree with that? Now this says the angle whose sine is x over 3 equals 5 pi over 6. wait a second. What does this notation automatically say to me? What quadrant? 1 or 4? Where is that angle? Is that possible? No, this problem has no answer. No answer to that one. Now let's try the next one. It's exactly the same situation. I don't know if it has an answer or not. Let's see. The angle whose tangent is 5x is the same as the angle whose sine is root 2 over 2. All right, so let's do this one first. Where is the angle whose sine is positive root 2 over 2? Quadrant 1? And how big is that angle? Pi over 4? So this is pi over 4. Can you have an inverse tangent? I'll just take that out. I don't want that confusing you. Can you have an inverse tangent in quadrant 1? Yes, you can. Right? Right? Okay. What do you think goes in this parentheses? I know it's 5x in the problem, but the angle whose tangent is what? Is pi over 4. What is the tangent of pi over 4? 1. So is this a true statement? Let me just write. Is that a true statement? Yep. So in order for this to be a true statement, I need that to be 1. Which means what about x? X has to be 1/5. Now you understand why that one didn't work, but this one does. It's that whole quadrant thing. You gotta make sure you're in the right quadrant. Alright, now we're gonna solve an equation. And notice we're going to find all the solutions. What does that mean, find all the solutions? Plus or minus 2 pi n? You want all of them. Okay. So it looks like an easy enough equation. So cosine equals negative 1/2. So wherever my answers are, they have to be over here. Would you all agree with that? This is where the cosine is negative. And if the x cosine is 1/2, the angle is pi over 3. But I'm over here, so it's going to be 2 pi over 3 and 4 pi over 3. Would everybody agree with that? So if my problem had the usual directions, then the answer would be x equals 2 pi over 3 and x equals 4 pi over 3. But because we don't have these directions, right, we need all of the answers. So we'll say, well, 2 pi over 3 plus or minus 2 pi n, where n is a whole number. Or I can say plus or minus 2 pi k, actually, plus 2 pi k, where k is an integer. It doesn't matter to me. Somehow you gotta write something like that. Okay? That pretty easy? Yeah, I think that one's not too bad. All right, what about A? Tan squared minus secant, and this one does have that, which means no plus or minus, just the answers. Any thought? Can't factor that guy. should be, you should have some awareness of a problem with a secant squared and a tangent in it. Because you know something about those two, right? What does that identity say? 1 plus tangent squared is secant squared. Right? So now how will that help me? Well, I can replace that. What can I replace that with? What's tangent squared? Secant squared minus 1. Move the 1 over. Now, why is that something that would be desirable for me to do, you guys? Because now it's all the same. Now it's all secants. Now I might be able to factor. So let's move the 1 over. I factored it right, to double check that, make sure. Does that look okay, factoring wise? Okay. So secant equals -1 or secant equals 2. Again, you have your style, I have mine, I don't do secants. So I'm going to say, okay, if the secant is -1 over 1, then the cosine is 1 over -1. And if the secant is 2 over 1, then the cosine is 1/2. Unit circle. Where is the cosine? -1. Pi. Where is the cosine 1/2? Pi over 3 and 5 pi over 3. Now it doesn't happen a lot, but it does happen sometimes. This problem has a tangent in it, and what did we say we kind of always have to be on, at least aware of with the tangent? Can't be pi over 2 or 3 pi over 2 because the tangent's undefined there. I don't have that here, so I'm good, but that is something you want to stay aware of. All right, next. Oh, Lordy, look at this mess. This is an inequality, so at some point I'll be having to do some shading, but let's see if we can figure out how to start first. Anybody have a thought? Got a factor, so I got sine squared, and then 2 cosine minus √2. Would you agree with that? So I really have 3 factors here. I have sine and cosine equals √2 over 2. Would you agree those are my 3 factors? Sine's in there twice, because that's going to be important for me to stop and think about for a minute. Now I need to figure out a way to multiply all these together and be greater than 0. Now, give me some ways. What are some ways that I could multiply these things together and be greater than 0? Well, this could be bigger than 0, bigger than 0, bigger than 0, right? So bigger than root 2 over 2. It could all be positive. So greater than, greater than, greater than. What happens if this is less than? If those are both less than, then that would have to be greater than. Now, could this one be greater than and this one be less than? No, because they're the same thing. So sine is what sine is. So we're either both bigger than or we're both less than. I think we've covered all the bases then, haven't we? All right, so let's look at our circle and see what that looks like. Here's my circle. Here is where the sine is 0. The sine is 0 here and here. Here is where the cosine is root 2 over 2, pi over 4 and 7 pi over 4. Would everyone agree with that? Now, if I want, I'll do this first case here. If I want my sine to be positive, then I am looking at that. And if I want my cosine to be positive, then I am looking at this. Jordan, you okay, honey? Try to stay awake. This is more exciting than you think. Now, what is my intersection? My intersection is, for this case right here, my intersection is from 0 to pi over 4. That's it. Now, for this case, the dots are in the same place. Okay, but you get the idea. That's where sine is 0. This time I need it less than, so it'll be all this. And then my green is still pi over 4 and 7 pi over 4. But this time, all of this. Oh, no, that's greater than. It's still this. It's still greater than. Sorry about that. So my intersection is from 7 pi over 4 to pi. Right here. All right, everybody? All right, give C a try. You and your partner. Give C a try. It's another inequality, so you're going to approach it very, very similarly to what we did here. 7 pi over 6 and 11 pi over 6 and pi over 2? Okay, so here's case 1. I did them backwards for some reason. My case 1 was greater than, less than. Is that okay with everybody? Gotta have one of each, because that's negative. So I said, okay, I gotta be bigger than my black dots. And I have to be less than my blue dot. Well, the whole circle is less than the blue dot, except for the dot. And then all of that is bigger than the black dots. So, are you seeing the same intersection I am here, this squiggly? We have to be careful how we write that though. Starting at 0, we're gonna go till we get to pi over 2, because that is not shaded in. It's a less than. So then I'll pick up again at pi over 2 and go all the way to 7 pi over 6. And then I'll pick up again at 11 pi over 6 and go all the way to 2 pi. So there is the answer to my first case. Does that make sense to everybody? Now, I said my second case was empty because I have to be above my blue dot, and I can't be. So, that's the answer. How many of you got that? Anybody get that? Oh, wonderful, wonderful. All the parentheses and brackets and everything, you got all that right? Super. Maybe we should have had our test today. Underestimated you, perhaps. All right, let's do this next one. Let's see if we can get this guy done before heading off to lunch. Now, I understand there's a decimal in the problem. Okay, that's the least of my worries. Right now, my main worry is what? What is alarming me? Cosine 2x. This is not good, okay? It would be okay, except I have a plane x. Can't do a 2x and a plane x. So, we're gonna change that cosine 2x. What are you gonna change it into? You have a choice. What is the best choice? Two cosine squared minus 1. And why is that the best choice? Because I already have, exactly, I already have a cosine in my problem, so I don't want a sine thrown in there. So 2 cosine squared minus 1 equals 9 cosine squared minus 4.5. So cosine 2x is 2 cosine squared minus 1. That's one of your identities. All right, so 18 cosine squared minus 9 equals 9 cosine squared minus 4.5. What do you suggest at this point? Could we, that's a fraction. Yeah, we could definitely bring that over. So 9 cosine squared equals, what, 4.5? Now, if you don't like the decimal, you could think of the decimal as 9 halves and times everything by 2. So we have 18 cosine squared equals 9. You don't have to do that, but now you don't have a decimal. So cosine squared equals 1/2. Right? And cosine equals plus or minus square root of 1/2, which is root 2 over 2. this was an equation, yes, so pi over 4, 3 pi over 4, 5 pi over 4, 7 pi. That's it, and then this is cosine 2x. Cosine 2x. We'll stop there. We'll pick up with these multiple choice when we get back. Everybody in your seats at 45, please. Have a good lunch. Try to leave everything intact over here, Lola.
I'm trying, Mrs. Ford.